Now question number 5, let's see what it says. It says a driver of a car traveling at 52 km per hour, okay, applies the brake and accelerates uniformly in the opposite direction. So this is something which is very important for us to know. Accelerates uniformly in the opposite direction. See, this is a keyword, opposite direction. That means it's a case of what is, this is a case of deceleration. So let me write it for you. This is deaccelerations. In deacceleration, what happens? Speed goes on decreasing. Speed keeps on decreasing. Okay, velocity. Fine. Okay. So the car stops in 5 seconds, and another driver going at 3 km per hour. This is what I have drawn for you. First car number 1. First car, it was driving at 52 km per hour, and it says it stopped in 5 seconds. Another driver going at 3 km per hour in another car applies his brake slowly and stops in 10 seconds. So this is second car, 3 km per hour. Time duration is given. So it stops every time. So in both the cases it has been mentioned stops. Yeah. So the car stops. Stops means the final velocity becomes 0. So it is silently given the problem. So on the same graph paper, plot the speed versus time graph for the two cars. Okay, so we have to draw and then we'll see what we have to do. So let us first analyze what all are given to us. Okay, so this is for car 1, which is given u1. This is the initial speed which is given in 52 km per hour. So I have converted into SI unit by multiplying with 5 into 5 by 5 by 18. Okay, so the speed will come to be, initial speed you will find 14.44 meter per second. Final speed v1 will be 0, as I stated earlier, right? And time duration in which it stops, t1 is equal to 5 seconds. So this physical quantities for car 1. Okay, now similarly for car 2, the same thing, same sort of things are available. u2, it says 3 km per hour, it will come out to be 0.83 meter per second. v2 is 0, t2 is 10 second. Now it is asking us to draw speed versus time graph. So I have already drawn. Okay, I have drawn for you. So this is the graph which I have drawn. Okay, just take a look. Along x-axis I have taken time, which is in second, and along y-axis I have taken velocity, meter per second. So see, the B point represents 0.83 and A point represents 14.44. Yeah, and this is C. C is at 5 seconds. So this is 5. This value is 5 and this value is 10. Okay. So since this is a case of deacceleration, means sort of acceleration. Acceleration comes into picture when velocity decreases uniformly. Yeah, it's a case of uniform acceleration. You can write uniform acceleration. So this is some catch, okay, which is hidden in the problem, that we have to keep in our mind. So this is uniform acceleration. Yeah, is a keyword. So that means what? That means what is the shape of the graph? It will be straight line. The shape of the graph will be a straight line. Yeah. So we have available all the points. So we can directly join and make a straight line. So if you go and join these stats which are available for car A, it will come along y-axis it is 14.44, along x-axis the value is 5. Okay, similarly for this is for car 2. So let us write for this is for car 1. And this is for car 2. It is as simple as that. So we have velocity time graph, can we calculate the magnitude of displacement, that is distance? Can we calculate? It is very simple. What it is? It is area of the curve line below. Okay, so in first case for car A, okay, car A, what will be the area, what will the distance covered? It is S1. I have denoted it by S1, and the value will come out to be half into AO into OC, half into 14.4 into 5. The distance will come out, the distance traveled is 36.1. Similarly, if you calculate the distance traveled by second car, it come out to be 4.15. So now the question it asks is, which of the two cars traveled farther after the brakes were applied? Yeah, which of the two cars traveled farther? So the answer is this one, 36 point car, first car. Yeah. Question number 6, figure 8.11. See, 8.11 shows the distance time graph of three objects A, B and C. Okay guys, distance time graph. Study the graph and answer the following questions. Yeah, this corresponds to graph of B, okay, C, and this is A. Okay, so it asks us which of the three is traveling the fastest. Okay, so which of the three is traveling the fastest? How can we answer this? Any idea? We have distance time graph. You are covering faster or slower. We can answer this question in terms of speed, by knowing speed. If we know speed, we can say which one is traveling faster or slower. Okay, we have distance time graph available with us, and we want to know speed. It is very simple. Knowing speed is how to know speed, guys. The formula of speed from a distance time graph. Yeah, distance time graph I am writing in short, ST graph. S, we know it is distance, and T is time. Yeah, from ST graph, what is speed? Speed is equal to slope of the curve. In our case, what is the nature of the curve? It is a straight line. Yeah, so that means the speed is what? Speed is constant. So knowing the slope of a straight line is very simple job. It is just tan theta. That means it is tan theta. Yeah, tan theta for a straight line. Let me write it for you. For straight line things. So for a straight line graph, what is the slope? What is the speed? It is the slope of the straight line, so which is nothing but it is tan theta. Okay, guys, we have three objects available with us. Okay, and we have three types of graphs available. Yeah, so what do we need to do? We need to, so suppose let us call uh, this corresponds to B. Yeah, so we can say the angle which it has is, let's say let me mark it as red pen. The angle which it forms is theta B. Are you able to see theta B? And which graph is this? This corresponds to C. This is theta C. Now we have A. This corresponds to theta A. So now we need to calculate three values of tan theta. So that means we need to calculate tan theta A. We need to calculate tan theta B. We need to calculate tan theta C. Yeah, from your trigonometry, you must be knowing that as theta increases, okay, theta increases, this marks increases, okay, the value of tan theta increases, the value of tan theta increases. Fine. As theta increases, the value of tan theta increases. It is as simple as that in the simplest term. So let us see which one which of the curve which of the straight line has the largest value of the angle with the horizontal axis x. Theta b, theta c, theta a. By seeing this, you will find that theta b is the largest. Okay, so the answer is, which of the object is traveling the fastest? Object b. Object b is traveling the fastest because value of tan theta is the largest. Is the largest. Yeah. So we are done with part A. Now let us see what is saying. Are all the three ever at the same point on the road? Okay. So let us try to answer these questions. This is a distance time graph. Yeah. if if you know distance, if you know time, okay, you can find out distance or vice versa. Suppose the two curves, so let us analyze this point. Okay, this is the curve which corresponds to b and c. B and c meet at this particular point. So at this particular time, okay, approximately 7 hour, sorry, 0.7 hour, you can say, both are on the same distance. Because how to know the distance? Just draw a perpendicular from this point. Yeah, we'll have the same length in both the cases. So we can say this is a point where b and c meet each other. Another such point, this c and a meet each other here, because at this particular time, okay, distance covered by c and a both will come out to be same. Yeah, similarly, yeah, these two are the intersection. So are you seeing any point where all the three objects, yeah, are meeting together? That means, are you seeing a point where all the three through which all the three lines passing together? See carefully this graph. We have three intersection, this and this, two objects, this also two objects, this also two objects. There is no such point. Okay, so the answer is no. The answer is no. B part answer is no. So what is the reason? You can suffice this particular reason in your exam. Yeah, this is something I have written for you. The reason is, the given graph is a distance time graph. Okay, in order to meet all the three objects, there should be a common point, guys. There should be a common point where all the three graphs intersect each other. Okay, but there is no such point. Fine, so answer is no. Yeah, let us take third C part. How far has C traveled when B passes A? When B passes A, so first of all, let us try to find out the time stamp when B passes A. At what time B passed A? This is the graph which corresponds to B, and this is the graph which corresponds to A. B passes A at this particular time. Yeah, are you seeing, guys? This particular time. At this particular time, B passes A. Fine. So at the same time, what is the position of, so let us put our this scale here. This is how we used to analyze a graph. Yeah, this is the time when B passes A. So this is the corresponding distance for C. Yeah, so approximately it will be, it is passing through the, approximately it is passing through 8 approximately, yeah, if you want you can find it out, but approximately you can say it is 8 kilometer, yeah, when B passes A. But there is a catch here, yeah, at this particular time it is 8 kilometer. That is fine. One thing, what is the initial position of the C? C started its journey from this particular point. Note that. So we have to take into consideration this particular distance as well. So just count the blocks. 1, 2, 3, 4, 5, 6, 7. That means 7 blocks constitutes 4 kilometers. So we can find out the value of distance from 4 blocks, and that particular value we need to subtract from this value, and then we can give the answer. So this is what the problem is talking about. Yeah, so all this homework I have done for you. So let us say at time t equal to t1. Okay guys, the object B passes A, yeah, at t1 the position of C is p1. I have marked it p1. From the graph it is coming 8 kilometer approximately. You can mark, you can write approximately also. It is better to put this word, this will always save you. At t equal to 0 the position of C is how much? This is 4 blocks. So how to calculate? So 7 blocks, we have already discussed that 7 blocks corresponds to 4 kilometer. So just apply unitary method. 4 blocks will corresponds to how much? 4 by 7 into 4, 16 by 7. Okay. So we need to subtract this value from this 8 kilometer. So what will be the distance traveled by C? So at P0, what is the value? It is 16 by 7 kilometer. And how it is coming? It is coming this way. So let me put a mark here. We have got this value from this 16.7, right? So the distance traveled is how much? 8 minus 16 by 7. If you calculate it, it will come out to be 5.72 kilometer approximately. Again, put a word approx. This is the best word to get you saved in your exams. Yeah, so let us see what the D part talks about. How far has B traveled by the time it passes C? How far B traveled by the time it passes C? Yeah, B passes C. So let us see when it. This is the curve for, which one is the curve for C? This is the curve for C, and this is the curve for B. So B passes C here. Are you noticing this fact? This corresponds to B, this corresponds to C. B passes C at this particular time stamp. At this particular time stamp, B passes C. So it is asking how far B traveled. We can calculate. So for that, what do we need to do? We just need to put on perpendicular here. So if you put a perpendicular here, right? You just go on and put a perpendicular here. Yeah. You will find that it comes out to be how many blocks? 10 blocks. 1, 2, 3. Anyway, this is 7 blocks. 8, 9, 10. 10 blocks. So now again we have to do that kind of calculations. Yeah. So in order to get the answer, what you need to do? You need to do one thing. You know 7 blocks corresponds to how much, guys? 4 kilometer. So same unitary method will apply. So how much is the 10 blocks? 10 blocks is 4 by 7 into 10. So the answer will be 40 by 7 kilometer. There is no harm in putting approx word because we have read the graph. Okay. Now question number 7. Okay, a ball is gently dropped. This is a keyword. Gently dropped from a height of 20 meter. Hmm? So there is a ball which has been dropped. This is a ball which has been dropped from a height of 20 meter. Yeah. If its velocity increases uniformly, again this there is a keyword, increases uniformly. Yeah, means what? There is a accelerations at the rate of 10 meter per second square, which is written. With what velocity will it strike the ground? After what time will it strike the ground? So there are two things we are supposed to find out: final velocity and time of travel. So let's see what is given. So this is a ball. Yeah, it has been released from here. So that means it is u equal to 0. But it is as simple as that. Acceleration is acting downward. So the moment it will reach here, it will have some significant velocity. So let us write down what are the factors which are available with us. What are the values? Yeah. So what are the values which are available? So it says silently that u is equal to 0. That we have to understand, because it is written that gently dropped means it has initial velocity is 0. What is the height? Height, you can say it is 20 meter. I will say plus 20 meter. Let me explain to you. And you see, we are going to analyze. So this is a motion along a straight line. Okay, in this case the motion is taking place along y-axis. So there is a need of adopting a sign convention. We know this fact, we have discussed this fact multiple times. So let us choose downward direction, okay, as positive and upward negative. It's very simple. And going forward we will stick with this particular sign convention, and we'll write down the value of every physical quantity, keeping in mind this fact. So what is the height available? So height 20 meter, so it will be plus 20 meter, right? What is acceleration? We have the value of acceleration available with us. So it says acceleration is 10 meter per second square. You tell me, plus 10 meter square or minus 10 meter square? Velocity increases. Yeah, so acceleration will be acting downward, right? So this is something which we have to derive from the problem. Yeah, so again acceleration will be positive, okay? With what velocity will it strike the ground? So it is asking us to calculate v. What is the time of travel, this distance? So again this problem is very simple, we can solve this. So let us try to solve it. So we know there are three equations. We have u, we have h, or we have a. Yeah, so we have three equations of motion. So let us use that. We can go for this particular set, v square equal to u square plus 2s, because we have to calculate v, we have u, we have a, we have s means h in this case. Okay, we have h. Yeah, so we can apply this. So let us apply and find out. So v square is equal to u square plus 2ah. How much it will be? So anyway, u square is going to be out. Yeah, agree, because initial velocity is 0. So it is simple, 2ah. So it will come out to be how much, guys? 400. Yeah, it is square. Now we have to find out velocity. What is the velocity? It will be root of 400. So it give us two values. Just note here, it give us two values, plus minus 20 meter per second. Means we have two values. One is plus 20 meter per second and another is minus 20 meter per second. Yeah, because if you multiply minus 20 into minus 20, it will come out to be plus 400. Similarly, 20 into 20, anyway, it is 400. So which value we should go for? Any idea? I think you should be able to answer, because the ball is moving down. So the value of the final velocity will be this, and we need to discard this. So this is the fact which I have written here. So since the ball is going down, that is positive direction, hence v should be positive. So this is something which we are deriving from here. So we are done with this calculation of final velocity. Yeah. So now we can apply. So since v equal to ut, v equal to u plus at. Okay. So can we calculate time of travel? So I think it is very easy. V minus u by a. So we can calculate. So it come out to be how much, guys? Final velocity is 20, initial is 0, time taken is, sorry, acceleration is 10. So what is the time spent? 2 seconds. This is a very simple problem. Yeah, problem number 8. The speed time graph for a car is shown below. Yeah, this is the. So before jumping on to this particular question, so let us analyze the graph first. The speed time graph and the nature of and the shape of the curve is not linear. So that means the speed is not increasing uniformly. Okay, right? Now let us analyze. Find how far does the car travel in first 4 seconds. Set the area on the graph that represents the distance traveled by the car during this period. It is asking us to do two things in part A. It is asking us to set the area. The area which lies under speed time graph gives us magnitude of displacement, that is distance. It gives us distance. Yeah. So use your scale and you will find that at time t equal to 4 second, the speed is 6. Yeah. So the point will come out here, somewhere here. So in order to find out, so it is asking us to set the area. So you can set this area with a colored pencil, okay, in your exam. So that is totally up to you. Go ahead and color it. Okay. It is asking us to find out the distance covered. So what we need to do, we need to calculate the area of this particular section. See this things closely. It appears that it is a quarter of a circle, but it is not. You might be asking why? Because the length of this line is 6 and the length of this line is 4. Yeah, that means radius is not same, so it is not a quarter of a circle. This is not a geometrical shape. Actually it is something else, so which you will study in class 11, but for now this is not a geometrical, this is not a quarter of a circle. So now then, how to find out the area which lies under this curve till t equal to 4? So I have drawn the same curve, okay, till t equal to 4. Till t equal to 4, I want to make you understand one thing. So that's why I have drawn the curve explicitly on a piece of paper. Okay, ignore this. This is something which is wrong. I was doing something else. So here on x-axis there is time, so t in seconds, and along y-axis speed v in meter per second, that is. And I've drawn a curve which is shown in green color. Fine. Here the unit is it has taken 2, 4, 6, 8, and I have gone with 1, 2, 3, 4 because we want to explain something. There is some purpose behind it. Okay. Again, I have splitted it 1, 2, 3, 4, 5, 6. So at 2, what is the corresponding speed? 6. Fine. At 2, so not at 2. At t equal to 4, the corresponding speed is 6. At t equal to 4, the corresponding speed is 6. This is the point here. It is asking us to find out the area of this particular section. Use your scale. draw a perpendicular. So now this time you can see it clearly that it is not a geometrical shape. It is more evident that it is not a geometrical shape. You are required to find out the area which is lying under this curve. So what is the way? There are multiple ways. If you go ahead and find out the area which lies under this triangle, okay, let me first put this in blue color. Okay, now I'll use my pencil so that I can erase it. I'm just trying to explain the things. There are ways. So you can find out the area of the triangle. Yeah, half into base into height. In that case, you will ignore this particular area, this much area, which is quite significant, I think. Don't you see? Right? Then what is the other way round? So let us erase it again. We can do one thing. We can divide this in two parts. Let us find out the distance which has been traveled, which is traveled by the object in first 2 seconds. In first 2 seconds, where it will come in your graph. So in first 2 seconds, the speed is 7 blocks. 7 blocks. Okay, so let's try to find out the value of speed which corresponds to t equal to 2 seconds. How much it is coming? 7 blocks. 1 2 3 4 5 6 7 7 blocks. So we will use here unitary method. 3 blocks corresponds to 2. Okay, so we have divided into two parts. So in first part, we are trying to calculate distance traveled in first 2 seconds. So how much it is coming? It is coming 7 blocks. So what is the meaning of this 7 blocks? Let us see. We know that 3 blocks along y-axis corresponds to how much? 2 km per hour. Sorry, yeah, 2 meter per second. So now we have 7 blocks. I think we can calculate. It will come out to be 2 by 3 into 7. That is 14 by 3. 14 by 3 meter per second. Okay, guys. Distance, not distance traveled. Sorry, I'm extremely sorry for that. This is not distance traveled. This is value along y-axis. You can write value along y-axis. Okay, in first 2 seconds, it is coming to 7 blocks. 3 blocks we know 2 meter per second, and hence 7 blocks is equal to 14 by 3 meter per second. So now can we calculate the area? Let us see. So where it will come to 14 by 3, if you calculate, it will be coming to 4.67. yeah, it will come out to be 4.67. 4.67. Now let's go back here and sorry. So at 4.67, so at t, the value will be here 4.67 approximately. Yeah, use it precisely. Okay, and the calculation may go wrong here. So we are dividing it in two parts. So in this case, we would be able to calculate this much area, this triangle, fine. And this shape, can you tell me something about this particular shape? This is a trapezium, right? So how much area we are going to ignore in this case? We are going to ignore this much area. So altogether, how much area we are going to ignore? This plus this. So in comparison to earlier case, okay, in which we were about to ignore this much area. Ignoring this much area is leading us to a better precise value of distance traveled. Yeah, so we should go by this approach. So that is the reason I have divided the solution in two parts. So in part 1 we are calculating value of v, value along y-axis, whatever, in first 2 seconds. Yeah, it is coming to 7 blocks, which is coming out to be 4.67 meter per second. Yeah, so now let us give some name. Is a, this is b, this is c, this is d, this is e. Yeah guys, okay. So what is, let us call it S1. S1 is how much? S1 is, in first part, it is half of AB into BC, half of, what is the value of AB, 2 into what is the value of BC, will come out to be 4.67, no, or 14.3. yeah, so 2 to cancel out, so 14/3 meter. Fine guys, now let us calculate distance traveled between 2 seconds and 4 seconds. This is very simple. This is, let us call it S2. So what is S2? Area of the trapezium. We denote trapezium, we can denote it by this. What is the name of the trapezium? BCED. We can call it BCED. Yeah, BCED. We know the formula. So half into sum of the parallel sides. What are the sum of the parallel sides? BC and DE. BC plus DE into height. Height is BD. So I think we can calculate now. So it will come out to be something 2 into, what is BC? We know it is 14/3 plus, what is DE? D6, and what is this? 4 minus 2, that is 2. So we can calculate this. So it will come out to be 14/3 plus 6, 32/3 meter. What is the total distance which is covered? Hence we can calculate S equal to S1 plus S2. Yeah, which is equal to how much guys? It will be 14/3 plus 32/3. So it will come out to be how much? It will come out to be 46/3 meter. So we are done with calculation of part A. We are done with the answer of part A. Part A is solved. Which part of the graph represents uniform motion of the car? Let us try to solve B part here. Okay, we are going to solve B part here. So B is talking about which part? Yeah, let us go back to the curve. So for uniform motion, what is required? If it is a speed time graph, we need to see that from which point speed becomes constant. So if you see clearly, so from 6 second onward, at 6 second the speed is this, and this onward the speed is same. Don't you see that? Agree? 6 second onward the speed remains same, so you can say it becomes uniform motion. Okay, so the answer is after 6 seconds the graph represents uniform motion of the car. Question number 9, what it says, state which of the following situations are possible and give an example for. We have to suffice an example here. Okay, which are possible and give an example. Okay, part A, an object with a constant acceleration but with zero velocity. Is it possible? with zero velocity and constant acceleration. I think it is possible. It is purely possible. So let me explain to you how it is possible. Suppose, yeah, just for some time we solved question, this question number 7. This is one example of that. Okay, let us do it again. You're here, you throw a ball. Okay, you are here, this is the ground. Okay, this is the ground, you throw a ball here in the upward direction. Okay, with velocity, say, do you know this is a ball, so a force will act on this. Due to that, it will cause deceleration. You know that. So that is called acceleration caused due to force of gravity. We denote it by G, letter G, and it acts downward direction. Its value is 9.8 meter per second. Yeah. So when you throw a ball, you need to impart a speed which is not equal to 0. Agree? Then only you can throw a ball. Yeah. You throw a ball from this particular point. This represents the ground. Okay, guys. You throw a ball. The initial speed is not equal to 0. So what will happen? After some time, it will reach to a height. Suppose at this stage you throw a ball with a speed of 5 meter per second. It will go up, and at some point of time, the speed will become 0. That means B will become 0. This 5 meter per second is what? Is U, right? And after reaching here, the ball will again come down, right? This is one part. This is part 1, and this is part 2. So in part 2, what is the initial speed? Initial speed is 0. It will reach the ground with some velocity which is not equal to 0. In both the cases, acceleration continue to act. 9.8 meter per second, 9.8 meter per second. So the value of acceleration is constant in both the cases, but velocity is 0. Yes, it is possible. So the answer is yes, it is possible, and you can suffice this particular example. Throwing a ball upward. Okay, upward motion and downward motion. During both the parts, at one stage the velocity is 0, right? But there is acceleration which is constant, 9.8 meter per second square. So an object with a constant acceleration but with 0. So this is done. An object. So before solving B, let us take C first. An object, there is some reason for that. I will explain it to you. An object moving in a certain direction with an acceleration in the perpendicular direction. So is it possible, guys? An object moving in a certain direction with an acceleration in the perpendicular direction. What it says that velocity of the object is in this direction and acceleration acts in a perpendicular direction in this direction. Is it possible? I think this is possible. Yeah, this is possible. Circular motion, this is absolutely possible. What we have studied during uniform circular motion, we have studied that at every point of time the direction of the velocity is along the tangent, but acceleration keeps on acting towards the center, and there is an angle of 90 degree. So acceleration is perpendicular to the direction of the velocity. So it is possible. So C is yes. So the answer is yes, and you can give an example of circular motion. Yeah. Now come back to B. An object moving with an acceleration but with uniform speed. Uniform speed means there is no change in speed. What is the formula of um, acceleration, guys? Acceleration is delta v by delta t. Yeah. So uniform, so this, it says uniform speed. Speed is same, but it is not saying that velocity is same. Yeah. So that means speed is same, speed I can simply say is constant. So that means velocity can vary. Agree? Why? Because velocity is a vector quantity, so it has two things associated with it. One is magnitude and another thing is direction. Magnitude of velocity, what this gives us to? Magnitude of velocity. Magnitude of velocity is nothing, it gives us speed. So magnitude can remain constant, but direction can keep on changing. Yes, this is also possible. So this is uniform circular motion. So see, this we have studied thoroughly. Uniform circular motion. The object keeps on traveling with a constant speed. Speed is constant, but acceleration keeps on acting perpendicular to the direction of the motion. Yeah. So this is again possible. So now B part is answer. So there was some intent behind that. After solving C, you can easily solve B. Yeah, because while solving C, we learned that in circular motion, velocity is along the tangent of the circle and acceleration act towards the center, and there lies an angle of 90 degree. But in B part, it is simply there is an add-on, that is speed is constant. Yes, no problem. So what is the example? Uniform circular motion. So you can write uniform circular motion. So the answer is yes, this is possible. Okay, guys. Now this is the last question which we are going to take. Question number 10. An artificial satellite is moving in a circular orbit of radius is given. Yeah. Calculates its speed if it takes 24 hours to revolve around the earth. It's pretty simple, I think. Yeah, guys. It's pretty simple. This is a satellite and it is revolving. This is earth. This is earth. Let's say this is earth and this is satellite. This is revolving around the earth. Let's say in this direction. Fine. Radius is given to us. Radius is known. We know radius. We also know t. So let us see what all values are given. So radius is how much? 42250 kilometer. We do have time. It is denoted by capital T. Capital T means time taking in revolving in completion of one round. Yeah, that it denotes. So that is 24 hours. So what we are required to find out? We are required to find out speed simply. So that is very simple. So what is speed? Speed is distance traveled by time. So what is distance traveled? It's a circular motion. So distance is periphery of the circle, and this T is capital T. Agree? So how much it will be? 2 pi r by t. Now go ahead and put up values. 2 into 22 by 7 into 42250 divided by 24. If you solve it, you will find your answer to be approximately 11065.48 kilometer per hour. Okay, it is a good way to put approx word here. it will always save you. So it is very simple. So now we are done with all the exercise questions. So now I think I have empowered you guys with enough knowledge base. So I expect you people to solve any questions which is related to your motion topics. Okay, in case you come across a problem, be it numerical or a theoretical question, and which you are not able to solve, or if you have any kind of doubt, so feel free to post your uh, query, okay, in the comment section of this video. So I think I'm done. Thank you guys, we'll meet again. Have a good day.